Okay, so for one of the problems that I gave you, I asked you to analyze this circuit. And that means find me the equivalent resistance of the whole circuit, the total circuit. I want the current of the total circuit. I want I1, I want I2, I3, I4, and I want the voltages through each single one. Now that is a lot to ask for. I know, I'm a demanding person. It's who I am. But let me help you do this right now, okay? So let's make a little chart. This is actually my favorite way to do this. I R, and then you know what? We can throw in a little power in there because, like I said, that's just who I am. So we can do the total. We can do 1, 2, 3, and then 4. So let's see if we can do this. Let's see how neat this will be. Hey, not horrible. All right, so okay, so let's see what we can actually do here in this situation, okay? So let's find out. Well, the voltage of everything should be 12, okay? Boom. Let's write down our knowns. 12 volts. Let's also know, let's call this 1, 2, 3, and then 4. So R1 is going to be 8. And let's assume this is in volts, this is in ohms. I won't write the units. Excuse me. Oh, sorry. Whoops. This should be in volts, this should be in amps, this should be in ohms, and then this should be in watts. So let's see. 2 will be 5, and then 20, and then 6. So this is what we know for certain. And we should also remember a few things, that the voltage between 2 and 3, the voltage between 2 and 3 should be equal. The current at 1 and 4 should be equal, as well as that will be the current coming out. Okay, so let's see what we can do. Okay. Now, in order to find everything, I want to find the resistance of the whole thing. Okay, I want to find the resistance of everything. So in order to do that, I need to combine what I can. Can I combine this and this? No, I cannot. I cannot. Can I combine this and yes? Yes, but that won't be helpful right now. In order to combine everything, imagine order of operations, PEMDAS, right? I need to figure this out first. This is in the parentheses first. Then I can add it to everything else. So my total resistance, R total, is going to equal R1 plus my R equivalent plus of these two. R equivalent, we can do 23 mJ, and then R4. So if you were to write it all out in a calculator, you can do R equals 8 plus parentheses 1 over 5 plus 1 over 20 to the negative 1 plus 6. So if you're to do that, that'd be 14, but don't forget that'd be 14 plus, and then right here we can do to 20, so that would be 4 over 20 plus 1 over 20, that would be 5 over 20 to the negative 1. So my R total would actually equal, that would be 4. So that would be 18 ohms. Here, let me do this in a different color so you can see that this is now, these are our knowns and this is a calculation. So kind of, you know, this is like a Sudoku. It's kind of cool. Let's figure this out. What else can I figure out? Well, do you remember V equals IR? So we could actually find the current running through the whole system because I have this and this. So let's do that. If V equals IR, okay, so we did that already. I will be equal to V over R. So I is equal to 12 volts divided by 18 ohms. I, if I round it, is 2/3, but if I round it, it would be 0.67 amps. So this would be 0.67 and then amps. So that's my total current, but that also equals here, and not here, but it will equal the same here, 0.67. Okay, so let us figure out, again, Sudoku. Forget about this, Sudoku. Oh, look, I have this open space and I have that open space. Let's use this and this to find out the voltage through here. So if I were to multiply 2/3 times 8, this is the part that's tricky on these online classes, is because if you do this times this, it would be a little different than if you were to multiply 8 times 2 over 3. That, of course, would be 15 over 3, so it'd be 5 1/3, so 5.33. But if you did this, you would get something along the lines of 5.37, I believe, or 36. So let me change this, I guess, for the next round. 5.36, and then 6 times that, again, 2/3 times 6, that'd be 12 over 3, and then you'd be able to figure that out. But in my situation, I think that would be, one second. So for this 4, if you were to multiply that by the actual fraction, it would be 6 times 2 over 3, which would be 12 over 3, which would be 4 on the dot. But if you were to multiply it by this, it would actually be a tiny bit more. But let's just make this as 4. Maybe I shouldn't have written it in that color. That's okay. I'll just write this to make it pop. Okay, so that's what we have figured out. Now here's the tricky part, okay? Here's the tricky part. This is the part where it gets a little complicated. Now we have to use the reasoning, these skills that I've taught you before, okay? So let's do two things, okay? So we'll call this I1. I1 has to equal I2 plus I3. And we can figure this out later, okay? So remember, because this current gets split up into this route and that route. Now that will be useful later. We can't do that right now because we have to figure something else out first. What we have to figure out is actually the voltages. But look, here's the thing. My total voltage, I'm going to write two equations because they're both true. My total voltage is going to equal all of the resistor, the voltages across the resistors through each path. So if I go through this path, that would be V total equals V1 plus V2 plus V4. If I go through this path up here, that would be V total equals V1 plus V3 plus V4. So let's write both of them down. Plus V3, because we're going up this way, plus V4. So I know what my total is. It's 12. And I know that this one is 5.36. And I know that this is 4. So 3 has to be the difference. So in this situation, you should know that V2 is equal to V3. Okay, remember that. They are identical, which is equal to V total minus V1, and then I guess I could put this in parentheses, plus V4. Remember, it's got to be the sum of this and this, and then subtracting from the total. So let's do that real quick. So V2, which equals V3, is going to be equal to 12 volts minus, and then the sum of both of these. So that would be 5.36 plus 4, 9.36 volts. So V2, which equals V3, is going to equal what? That should be 2.64. 2.64 volts. So then I can write that up here. Each one will be 2.64 volts and then 2.64 volts. Now, there's multiple ways in which you can do this, or this is the best way to check your answer, whatever the current is. So in order to find the current, we must do what we did here. V equals IR, and then I will equal, let's call I2 equals V2 divided by R2. So if you did that, you'd have 2.64 volts divided by 5. Okay, plug that in. 1 second. So my calculation, this would be 0.528 amps. So this would be 0.528. And then for I3, do the same thing. So I3 would equal V3 divided by R3. So that's 2.64 volts divided by 20. If you're to do that, I3 would equal, it would equal 0.132 amps. Now to check our work, let's add both of those. So if I were to do 0.132 plus 0.528, would that be that? I think so. I think it would be that. So that would be 3. It would be a tiny bit off because that would be 0.66 instead of 0. Actually, no, that would be correct. So hey, it worked out. Let me work on the power now. So that's most of what we have to do. But let's work on power just because. Let's not do all of them. Let's just do 2 of them. Let's do the power here, and then let's do the power here. Okay, so remember the equation for power is my old professor Ivy. There are multiple equations, but this is my favorite. So power is going to equal I times V. Simple enough. So 0.67 amps times 12 volts. So 2 over 3 times 6, 36. Excuse me, 24, actually 24 over 3. What is that, guys? That is 6. Actually, that would be 8, of course. 8 watts. Now for the total. So that would be 8 watts. Let's do here. If I were to do P equals IV again, but this was total T, let's do 4, P4, V4. So P4 is going to equal to 4 times 2/3, right? So that's going to be this, it's going to be 8 over 3. So that would be 2.67 again watts. 2.67 watts. You know what? Let's do all of it. Since we're already here, let's do it all. Let's do it all. Okay, let's do 1. P1 equals I1 V1. So P1 equals 5.36 times 0.67. Remember, this is volts times amps. I will do a calculation real quick, and then if you do this, this should come out to the same answer. But let's do P2 equals I2 V2, and then P3 equals I3 V3. Okay, so if you do that, I'll write this answer here. P1 equals, P2 equals 2.64 volts times 0.58 amps. P2 equals, and then P3 equals 2.64 volts times 0.132 amps. P3, give me 1 second to do the calculations, please. So I did the calculations and they're right here. So P1 is 3.59, P2 is 1.39, and P3 is 0.35 watts. The interesting thing here is that it's similar but a little different than the voltages, because remember the voltages, it's the sum of the voltage drop through one route. So again, that'd be 12 volts would equal to V1, V2, and V4, or V1, V3, and V4. For the power, it's actually the sum of the power of the circuit. So if you actually add this, this, and this up, it would equal 8. It might be slightly off because of our rounding errors, but it will essentially be 8. So hopefully this showed you how to find this. I might make another video with another example. Until next time, everyone. Bye.